Welcome back to your 15-minute science lessons, the free online learning to support you with your GCSEs. I know it's been a while since my last video, but I am back and I'm committed to supporting you get the best GCSE grades that you can. So our first 15-minute science lesson is on atomic structure, so let's go. To start with, this is the classic atomic structure diagram that you may see in any exam paper, in any textbook and in any classroom. So to start with, we need to be able to label what is in the atom. Now, in terms of the particles that make up an atom, they are called subatomic particles. Now, that sometimes confuses people when that's used in an exam. Subatomic particle just means within the atom. So if we start with the centre of the atom, then the centre of the atom, which of course is called the nucleus. Inside the nucleus, you will find two of your three subatomic particles. The one with no charge, that is your neutron that is found in the nucleus. And the second subatomic particle found in the nucleus are our positive protons. Now, this diagram is not really accurate because the protons and neutrons are roughly relatively the same size. In this diagram, it's showing that there's a difference. And actually, the smallest of the three subatomic particles, again, not reflected in this diagram or many diagrams, to be honest, is the electron. So the electrons are found on the shells orbiting the nucleus, and they orbit the nucleus at fixed distances. So these circles here, this is just the pathway. They can be called the shells, they can be called the orbitals. And they are fixed distances, so your first shell, so this one here, would always be the closest to the nucleus, and then each shell gets further and further away. Now, in terms of these three subatomic particles, as well as being able to name and locate them, you do need to know something about them as well, their mass and their charge. Now, the charge, people tend to remember that the most, and this is depicted quite nicely in this video. Protons begin with P, they are your positive subatomic particles. So then you would think, well, neutrons, they begin with N, so they're negative. Unfortunately not. Neutrons are your neutral, they have no charge. And then the electrons, they're the negative subatomic particles. So if we were to look at the atom, it does have positive and negative areas. So the nucleus is the positive area of the atom, and it's positive because of the protons. That's what's making the nucleus positively charged. And then the shells, the electron shells, the orbitals, they are negatively charged. And it's actually the attraction. Remember, in chemistry, you'll see this a lot. Opposite charges attract. And it's the attraction between the negative electrons and the positive nucleus that holds these shells in place. And the closer the shell is to the nucleus, the stronger that attraction. That attraction is called electrostatic attraction. The second thing you will need to know about these subatomic particles, and I'll go with orange, is their mass. So it's relative, so we're not going to put any units towards it. And the easy way to remember this is if your subatomic particle is in the nucleus, it has a mass of 1. So all of the mass of the atom is concentrated in that dense nucleus in the centre. Now, electrons, you could put 1 over 2,000. It's very, very small, but in your GCSE, putting 0 for the mass of the electron will get you the mark. So it's easier to remember than the small decimal number. But we know in terms, if something's got no mass, that's obviously not possible, but it's very, very tiny, that your mark scheme will allow you to have 0 and still get the mark. Okay, moving on then, and we're just going to summarise this in this table, and this might be a good opportunity for you to pause the video and see if you can fill this in based on the information that I am showing you. Just get the pen on. So pause the video. I'm going to go through the answers in a second. Okay, so the proton we know is in the nucleus, so it's got a mass of 1, and so is the neutron. So they both have that mass of 1, that relative atomic mass of 1. And then the electrons, are not in the nucleus, they're the smallest, and therefore they've got a mass of 0. Charges, protons are positive, +1 or positive, electrons are negative, and neutrons are neutral. So well done, guys. Give yourself a mark out of 6. Moving on then in terms of, right, well, how do we apply this then? So every element will have protons, electrons and neutrons. We know where they are in the atom. We know their mass, we know their charge. Now we need to know, well, how do we work that out for every individual element? So you will get a periodic table in your exam. You can see it now on the screen, and it has got a key. I'm going to go through that with you in a second, but we're just going to focus on how the two numbers can help you with the atomic structure. So this bottom number is called the atomic number, or it's called the proton number. Now that's obviously, hopefully, pretty self-explanatory. That is the number of protons that that element has. So lithium has 3 protons. And you can see, and I'll zoom in to show you on the periodic table, this is what I'm talking about here. Let's see if I can highlight it for you. The proton number. So if you forget, that's what you need to remember. There is a key. The bottom number is the number of protons. The top number, that's called the relative atomic mass, has a symbol AR. So if you're seeing those two letters anywhere, that is referencing the top number. The relative atomic mass is the average mass of one atom of that element compared to 1/12 an atom of carbon-12. It is a mouthy definition, but it is worth 2 marks. 1 mark for saying it's the average mass of one atom of the element, 2nd mark for saying compared to 1/12 of an atom of carbon-12. Now this top number, this tells you the total mass, and we'll have seen from the previous slide here that anything that has mass is in the nucleus. The protons and the neutrons have mass, so therefore the top number is the total of protons and neutrons. Now if we know how many protons it's got by the bottom number, so I already know that lithium's got 3 protons. Well, if the total of protons and neutrons is 7, it's a straightforward subtraction, isn't it? You do the top number 7 minus the bottom number 3. So lithium has 4 neutrons. Well done. And then the final subatomic particle, well, how do I work out the number of electrons? If it's an atom, you can assume that it has the same number of protons and electrons. So if we don't see a charge. So what I mean by that, if it's just asking you, it's just got a symbol, there's no plus next to it, there's no minus next to it, then it will have the same number of protons and electrons. So lithium, no charge. So therefore, if it's got 3 protons, it must have 3 electrons. And you would be asked, for any of these, and remember the quick way of remembering, protons is that bottom number, electrons is also the bottom number, and the neutrons is the top minus the bottom number. So the way I sort of help remember it is we're never going to pick that top number for anything. So if it's asking us for any of the 3 subatomic particles, it's never ever just that top number. It's either the bottom number or the top minus the bottom. So this is definitely some material that you would be putting on a flashcard. Really, really important. Now another opportunity now, guys, to pause the video. I'll change the pen colour and have a go. Can you apply that? The number of protons, number of electrons and number of neutrons. And I'll be going through the answers in a few seconds just to give you that chance to pause it. Okay, so sodium, if we zoom in, sodium is here, so 11 is the bottom number and the top number is 23. So it's going to have 11 protons, 11 electrons, and then 23 minus 11 is 12. So give yourself a tick if you got that. Hydrogen, it's in the middle. Both top and bottom is 1. So 1 proton, 1 electron, 1 minus 1 is 0. Hydrogen is the only element that has no neutrons in its nucleus. Oxygen is here. We've got a bottom number of 8, top number of 16. So 8 protons, 8 electrons, and then 16 minus 8 is also 8. And you will find that there are quite a few elements where the number of protons, electrons and neutrons are all the same. And then chlorine, we've got here. We've got a decimal this time, so we've got a top number of 35.5 and a bottom number of 17. So we're going to do our protons, which will be 17, electrons 17, and then our neutrons 35.5 minus 17 is 18.5. Now you do get a calculator, guys. There's no bonus points for working out mental maths, and remember you are in that high pressure situation when you're in an exam, so always best to check it with a calculator. Now the reason I've put chlorine as the last one is this number here. You cannot have half a neutron. So why, when we're working out the protons, electrons and neutrons, does it show that chlorine has half a neutron? That's where we're going to in the next part. So I'm going to go for this one first. So chlorine exists as something called an isotope. So an isotope, and this is a really important definition that I'd like you to remember. So as well as that relative atomic mass, we've got isotopes. So isotopes are elements, we'll go for atoms, of the same element with the same number of protons and electrons, but a different number of neutrons. Same number of protons, different number of neutrons. And again, I did say that already, but the electrons are also the same. So isotopes, same number of protons, so that's why it's the same element, because it's the proton number that defines the element. So they are the same element because they've got the same number of protons, but they have a different relative atomic mass. They've got a different number of neutrons. And if we work it out with these ones, just like we have been doing, bottom number for protons, so they've both got 17. Bottom number for electrons, they've also both got 17. And then we're on to our neutrons, so 35 minus 17, so this one's got 18, and then this one has got 20. So they are both what we call isotopes of chlorine, because they've got the same number of protons and electrons, but that different number of neutrons. And you will have quite a few elements that exist as isotopes, so it's one thing to bear in mind. Another one that I think of on the periodic table that is a decimal is copper. So again, it's not that it's got half a neutron in its nucleus, that's impossible. It's the fact that it exists as isotopes. I'm going to finish with the white atoms are neutral. I'm going to go on to this one. So on the term of isotopes, you could be asked to calculate the relative atomic mass, that top number of an isotope, and it is a simple calculation. You'll be given 2 bits of information about each of your isotopes. You will be given something called the abundance. It's a percentage. It's how common that isotope is. And then you will also be given the relative atomic mass, the top number of each isotope. Now, if it's not done in a diagram form, the number will just follow the symbol. So it'll say chlorine 35 or chlorine 37. That number is that relative atomic mass, that top number. Now, this abundance means that if you were to sample all of the chlorine atoms that exist, 75% would be chlorine 35, and the less common one is chlorine 37 at 25%. Now, all we do is we follow this formula at the bottom. So we're going to call this one isotope 1, this one isotope 2. So AR, we know that's relative atomic mass, that's the top number. So 35 times the percentage, which is 75, plus, and then the top number on isotope 2, so 37, times the percentage, 25, and then we're going to divide that by 100. And guess what? No surprise, that's where the 35.5 comes from. Now, when you do get a question like this, just remember to do those checks. Your answer has to be between the top numbers that you're given, and it'll also be closer to the highest percentage, because we're really just working out the average number, aren't we, guys? Well done. And then finally, the last question that I'm going to cover in our 15-minute science lesson is, why are atoms neutral? So quick recap, we've done protons, electrons, neutrons, 3, 3, and 4. Now, when we're working out why atoms are neutral, we're only going to consider protons and electrons, because they're the two that have a charge. So 3 protons at +1 each, that's going to give you a +3, and 3 electrons at -1 each, so that's going to give you a -3. So although, like we've talked about, atoms have positive and negative areas, they've got that positive nucleus, they've got the negative shells, overall they have no charge, and that's because the protons and electrons cancel each other out. And the reason they cancel each other out is because you've got the same amount and they are opposite charges. So why are they neutral? Same amount of protons and electrons, which have opposite charges and therefore cancel each other out. Thank you, guys. You've been absolutely fantastic. Hopefully you've enjoyed that first science lesson. Again, I'm going to start uploading a lot more frequently. I know we're coming up to a big time in the year where we're starting to think about revision. Please comment if you've got any suggestions or any topics you want me to cover, and please give a like and a subscribe. Thank you. You've been